Okay, so we have a couple of things. First question was, which assumption is this? It wasn't stated exactly like that, but the answer to that is, well, there's only one assumption that's been mentioned. Okay? There are no implicit assumptions. Sometimes there kind of are, because you get into really difficult and involved proof, and this is difficult and involved enough for you right now. It's hard to avoid implicit assumptions where you assume that anybody understands this, and you got to really nail those things down, okay? So that's one thing, okay? So there's the assumption. I said, this is sort of a one-to-one thing. You got one mention of an assumption and one assumption, man. But that's not really what we mean by one-to-one in this context. So I just said sort of. Okay, well, okay. Then we have this statement: if one-to-one no other linear combination can equal W. Well, I didn't spell out why that is. Okay? So here in blue, that's probably unreadable, but we'll fill it in later, but I'll explain this. And you know, from back there at the camera, it might be readable. Okay, so W is, if this is so, if W is C1 T of V1 up through Cn T of Vn, then by linearity, W equals T of C1 V1 plus C2 V2 and so forth, which is what I wrote here. So I say i.e., that is, this statement, that is, W is T of C1 V1 dot 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 through Cn Vn. By the linearity, this says the same as this. You basically factor that T out. Although T's not an algebraic quantity, it's an algebraic operator, okay? And by linearity, you can do this, right? Okay? Now, then I said, and emphasized, I said, if, because somebody asked, well, how do you prove that? Well, I don't prove it, I assume it, okay? If W is a different linear combination, meaning another linear combination, right? Because I'm trying to prove that no other linear combination can equal W. Okay? So now we're saying if W equals D1 times T of V1 up through Dn T of Vn, now just another linear combination of T1 V1 or T of V1 through T of Vn. It's different than this one, meaning that not all the D's equal the corresponding C's. These coefficients aren't always the same, aren't all the same as these. They might be all but one, okay? Or maybe none of them are the same. But if there's any difference between the set D1 through Dn, coefficients here, and the C1 through Cn, the coefficients here, then it's not one-to-one. Why? Because D1 T of V1 up through Dn T of Vn is T of D1 V1 through T through Dn Vn. And if the D coefficients aren't the same as the C coefficients, this is a different vector in V that maps to the same W, right? And for that reason, this can't be one-to-one. Okay? Now, in not quite seeing why this is, you made me stop and think about it and justify it. When you're doing your own proof, you got to make yourself stop and justify everything so that nobody can possibly question your proof, and in such a way that you have to fill something in. Now, that was not my goal in writing this thing, because I started writing out the D1 through Dn, but then I just said, no, I'm just going to assert this. Keep ourselves in the overview of the proof to see how the proof flows. But that is a detail that has to be filled in before we have a final proof. Okay? Okay, so then I say if this is always so, by always I mean for all W's. Okay? Always so means for all vectors W in the space W. Okay? Then what's that mean? It means there's a unique linear combination of the T of V1 through T of Vn, okay? It's equal to that W. In other words, T of V1 through T of N is a basis. Okay? How does that contradict our assumption? Well, we just said that it can't be a basis because it's got too many vectors. It's too big. Okay? So, this is a pretty concise statement. So I can say, so it ain't so. I ain't 1 to 1. Okay? Make sense? That's kind of a neat little proof. Okay? Now if I was doing a textbook proof, I would have filled these details in as we went, but every detail confuses the next one. And it would be harder to see the sweep of the proof. At least I'm conjecturing that would be harder. I haven't proven that. Okay? You guys are the proof. So hopefully what I did was useful. Okay? And I think I am going to just ask you now to go ahead and write out a complete proof, textbook proof, and then compare it with the textbook's proof. I think they prove it. Okay? First you got to find it, but that's good for your soul.